How HashMap works internally in Java. Very popular interview question. I'm going to cover the internal functioning as well as whatever the related questions are there. So we are going to see one by one. So let's see the first thing. HashMap, what is this? What is the purpose? And we'll come to the internal functions of this. So HashMap is a widely used data structure that implements the map interface. So map is the interface that has contract about key value storage. So whenever we have to store key and value in such a way, so map is an interface that gives the contract about that, and there are different implementation of that one. HashMap is one such implementation that we are going to understand in more detail. So in Java, when we have to create a hash map, so how we create that? So we just have, there is a constructor of that one. Let's say hash map is this one, variable name I'm giving it this one, so new is the keyword, and hash map, this way we create it. So this is the generic way that we create. So there is more proper way, like you have to give it an angle bracket, this one, what is the type of key and what is the type of value. So I'm just avoiding that just to have a better readability in here. In this one, so HashMap, we are going to have a storage about key and values, right? So we should have a method around that. So the method is let's say map is there, so first put is there. So let's say integer is the key that I am making and value is the string type I am making. So 1 against that 1, and we have m dot put, let's say 2, against that I am putting 2, and the same way we have m dot put, let's say 3, and I am putting 3 as a value. And whenever I have to get something from this map, so for that also we have this m dot get, and I have to just pass the key. So let's say I passed key, so this will return me 1. So this is the usability basically, how we use the map. In this one we have to understand when we are calling put, how it is maintaining these key values that we have in the internal structure, right? So let's understand that part. So internally we have buckets actually. So let me draw that in here. So let's see, this is a bucket and this is a bucket, array of bucket actually, array of buckets. So when we have array, so we should also have indexes around it. So I'm naming it 0, 1, 2, 3, 4, 5, 6, 7 and so on. Initially I'm taking this one. So when we created this new hash map in such a way, internally this structure gets created. So what is the size of this structure? Initially this is the size of 16. I have put 7 only, but in actual size it's 16 that it gets created. What is being stored in this one? Let's go a bit up. So there is an entry class in the map itself. This entry class has attribute of key, value, hash, and there is a next. So it is a representation of first node of a linked list. So it is a, when we say array of buckets, and each bucket is a linked list. Initially each bucket is a linked list. Whenever, so let's say first operation, so now we got the structure how it keeps the element internally. So it is an array of buckets. In that bucket, every key value that we put, an entry object gets created, and that entry object will be stored at a particular index. So which index it gets stored, we are coming to that one. So whenever we call the m dot put, so whenever we calling map dot put dot 1, so this one, its hash will be calculated. We know every object in Java has a hash code method. That is how we get the hash code of that object. So whenever we calculate that hash, so that hash will give us the, so when we got the hash code, so we have to calculate where this hash will go in here, right? So we have to create a distribution around it. So internally in the map there is a method of hash to get the index out of this one, right? And this is a very good implementation of this one. It makes sure that the keys that you are getting from hash, it is properly uniformly distributed basically around it. So let's say first one, when we are storing 1, let's say it got the index of this one 1. So entry 1 will be stored in here. Okay, so when we are saying entry 1, it has 1 as a key, 1 as a value, and its hash, whatever, let's say it is getting 1 2 3, and next is null in this case. So this is the entry object that will be stored in here. Coming to the second one, when we are going to store map.put, the operation, the same step will be revised. It will take 2 to calculate the index in the bucket. Let's say in this case the bucket is coming as a 4, so entry 2 will get stored in here. What will have in this entry? So it will have a 2 as a key, 2 as a value, and let's say the hash code coming in as a 4 5 6, and next is a null, because this is the first node in the linked list in here. So this is how, whenever hash code is calculated, this is how this will be distributed. Now coming to the case when we are trying to put 3. So let's say when we get the hash code of 3, so 3 also got the index as a 2. So let's say 3 has a hash code, so let's make as a entry 3, and entry 3 has a 3, and this is value getting 3, and it has a hash code of, let's say, 6 7 8, but when index got calculated, it got the same bucket location, second index, right? So now, and the entry object is in this here is null. So now first hash code gets called and it is getting the index. Now this is the situation of this is the term that is known as collision, hash collision. We name it as a hash collision is happening. So how it gets resolved? So the second thing is the equals method. Along with hash code, we have equals method as well. So on that object, entry object, whatever you have created as a key, equals method will be called. Accordingly, this will be linked. Like this will be differentiated, right? So entry 1 and entry 2 will be different, and this has got the same index. So this null value will now change and it will point to the next index, next object that is in this one. So this will change in here. So this is how the linked list will be created. So any new key coming in, let's say this is again coming into this one, so entry 4 will be created and this will be linked again. So gradually this is how, if the unique key, unique index it is getting, it will get the unique bucket in the array itself. But if it is coming as a collision at any location, that linked list will be created and this will be updated in here. Now so far I hope you got the proper understanding. When happy cases are there, this is how it will work, right? Now coming to the scenario, like let's talk about the time complexity. So when we have this map.put, what is the time complexity when you get it? So let's see the first situation. Whenever you got the first index at first try only, right? So you just got the index and you put the value in here and return from there, right? So this is the order of 1 complexity that we are getting in here, right? For the average case, and also we can say that best case also order of 1 is coming. So let's say when we tried to put the second key, that also got the same hash collision occurred actually. Now I have to go to this first entry and check the equals method with the existing entry that I want to make it. It will compare that. If it is same one, then it will link to the further this one. So there is a 2 iteration of this one. Let's say one more key is coming in, again hash collision is happening. So we will get the linked list. So we will have this entire bucket in here, but because hashCode is giving the same index, so it will essentially be a linked list. So linked list, when we are inserting that element, what is the time complexity? It is the order of n, because I have to travel each and every element in the linked list and append that new element at the end. So that is how the worst case complexity comes as a order of n. And here is the catch. So if you are using Java 8 or latest version, Java 8 or plus version, this complexity can be reduced to order of log n. How? There is a size. Let's say there is a continuous linked list being made, and if that size, linked list size reaches 8 of size, that is the current implementation, that linked list will be converted into a tree, and tree will give us efficient insertion and as well as efficient retrieval also. So this time complexity of order mn will convert it to a tree, and it will give us the log of n complexity. Now we covered how the element gets ingested and how it takes care of the different scenario. There is one more case, like let's say there is a very good implementation of hashing in the keys that we are putting in, so there will be no collision at all. So let's say I tried to put number 4 key in here, and that again by that time all the keys, all the buckets that are full here, and it got the index 8 here, right? Now I have to resize the bucket. Basically I have to increment the size of the bucket, right? So that is how the resizing will happen. How that resizing will happen? So initially, as I told, the bucket size is 16. There is a load factor that comes into picture. Load factor, that is 0.75. So 16 into 0.75, the number, when this bucket is of that size, any new element is coming in, the bucket will be resized by the factor of 0.75 only. So it will plus that one, and that resizing will happen. That is how it will keep incrementing and keep adding the values in the map. So that covers all about the ingesting the element. When we talk about the get, the same operation will be here. So whenever we are trying to fetch a key, let's say 1, the hash will be calculated. Based on that hash, it will calculate the index wherever it is stored. So let's say it got the entry 2. Entry 2 has only one element, it will just return that one. Okay, and let's say it got the second index and it has a linked list in here. Now equals method will come into picture for the rescue. It will use the equals method to compare the next elements in the linked list, and whenever that match found, it will return that one. If does not found the match, it will return the null. Okay, so that is how the internal of HashMap and how it works very precisely. Now coming to the next one. So now let's see the related questions that can come around this HashMap and indicative answer as well. So what is the difference between HashMap and Hashtable? So the differences can be given in 3 points. First one is the thread safety. HashMap is thread safe, Hashtable is not. When it comes to null keys and values, HashMap allows one null key and multiple null values can be there. Hashtable does not allow any of the null key and null values. It will throw an exception in that case. Performance, due to synchronization, Hashtable as Hashtable has thread safety feature, so that there is a synchronization. So Hashtable is less performant than HashMap. So HashMap performs better when it comes to performance. Legacy, Hashtable is the legacy implementation and HashMap is the latest implementation. HashMap was introduced in Java 2, that is JDK 1.2. So next is, how does the concurrent HashMap work? So concurrent HashMap, this is used when we have thread safety, when we have to take into account thread safety. So Hashtable also had thread safety, right? So but the internal implementation of concurrent HashMap is in such a way that it provides better performance. So we understood that, right? So internally there is a bucket, array of bucket maintained, right? So the locking that it provides concurrent hash map, it provides that at the bucket label, whatever indexes that we say that segment lock. That is how it gives us better performance. So at the same time, number of threads can operate as the number of buckets are there, but hash table locks the entire map that is there. So that is how the concurrent hash map is better in that sense. The next one is that what are the implication of poor hash code. When we do not have a proper hash code, there will be more chances of hash collision. So that will give us the worst case time complexity around using hash code, around using hash map. So have a proper implementation of hash code so that those keys are distributed across the bucket properly. Explain the differences between HashMap and TreeMap. HashMap does not maintain any order. TreeMap maintains order. When it comes to performance, HashMap provides order of one-time complexity for basic operations like get and put. TreeMap provides order of log n because it keeps the ordering and it has to traverse all the elements that are there in the like internal structure, because it is keeping an ordering. So that is how, like, internally it is not array of buckets, actually it is a red black tree. So that is how this complexity, higher complexity comes into picture. Null keys, as we saw, HashMap allows one null key and multiple null values as well, but TreeMap does not allow any null keys in there. It will throw a null pointer exception. Usage, HashMap when we need a faster access without caring about the order. Use TreeMap when you need the ordering also. Next is what are the factors affecting performance of the HashMap. So that is like proper implementation of the hash code must be there. That is how like it can make sure that there is a proper distribution of the keys that are there, and equals method also. Whenever we have that properly implemented, it will make sure that HashMap is performing its best. Coming to the usage of HashMap in real-time applications that we have software in the industry. So let's cover one by one. Caching. Caching is essentially a key value, right? So HashMap is widely used in that case. Database indexing, used for indexing databases for quick data retrieval. Configuration storage, we have key value configurations that needs to be stored. So HashMap is used a lot there because we need a very quick and performant data structure there. So that is it about the HashMap. It covers a lot, like internals as well as what is the surrounding questions and applications as well. I hope you got the proper understanding about it. If this is the case, take a look at other videos, other interview questions that I already have uploaded, and the links are also given in the description box itself. So go ahead and check that out, and make sure that you subscribe the channel, share it with your friends, and hit the bell icon so that you get the notification when I upload any new videos. See you in the next one. Till then, take care. Bye bye.